Okay, so far in this unit, we have looked at area under a curve. We have looked at antiderivatives with the power rule, and we've learned how those two things are related to each other. What we're going to do in this unit, or this lesson, is find an antiderivative, but working backward from the chain rule. And we use a method that's called U-Substitution to make that happen. So the first thing I want you to do is just refresh your memory about the chain rule, and I would like you to find the derivative of this function. Three x minus 4 to the fifth. Pause for a moment, go find that derivative. Okay, I hope that was a good refresher for you. What I'm going to do is find the derivative in a slightly different way than what we've done before, because I want to set you up for this U-substitution method of working backward from the chain rule. So the first thing I'm going to do is think about this inner function. This inner function is what I'm going to call U. So U, the inner function, is 3x minus 4. And I know that in order to find the derivative, I need to multiply by the derivative of the inner function. So the derivative of 3x minus 4 is 3. Okay, so if I rewrite this function as in terms of u instead of x, the function is u to the fifth power. If I find the derivative of this is 5u to the fourth times u prime. If I replace u and u prime with those things that I found, then f prime of x, I'm going to replace u with 3x minus 4, and I'm going to replace u prime with 3. What we're going to do now is think about how to work this idea backwards. I'm going to use a problem that's just slightly more simple than this. I'm going to start with finding an antiderivative. So we're going to integrate this expression. Okay, we need to look at this and determine why we're going to use U-substitution. We need to figure out, why do we know that this was the result of the chain rule? So this is a derivative of something. What was the original function that gave us this derivative? So what stands out for me, and what you'll need to look at when you're finding an antiderivative, is that there is an inner function. So here's the inner function right here. That tells me I need to use U-substitution. That tells me this is the result of the chain rule. So if I let u equal x cubed minus 4, then what I can do is rewrite this expression as u to the 10th power. Okay? The problem is now we have a u in our integral and we have x's in the integral, so we need to change this so that everything is in terms of u. And I'll show you why this is going to be helpful, but we just need to get there first. Okay, so if I find u prime, I'm going to call it du instead. Du over dx, so the derivative of u with respect to x, is 3x squared. And du is 3x squared dx. So what I notice then in my integral is I have the 3x squared. I have the dx. So I can rewrite this as u to the 10th. And then the 3x squared and the dx, since the 3x squared times dx is equivalent to du, I can rewrite this as just u to the 10th power du. So now that problem that looked so complicated up above, because we had x cubed minus 4 to the power of 10 times 3x squared times dx, has all boiled down to this much more simple problem of saying, here was the derivative of the outer function, here is the derivative of the inner function. This is a chain rule problem. So all we need to do now is work backward from this u to the 10th power. Okay, so if I work backwards from u to the 10th power, I end up with 1/11th u to the 11th plus some constant c. If I replace u with x cubed minus 4, then that gives me the original function that gave me this as the derivative. Now let's check that though, because that just feels weird. What happened to that 3x squared? Where did that just go all of a sudden? So let's find this derivative and let's check our answer to make sure that what we did is the correct antiderivative. So I'm going to differentiate 1/11th x cubed minus 4 to the 11th power plus this constant. I'm going to find the derivative. So what I need to do is use the chain rule, which is exactly what we realized from up above. So I'm going to use the chain rule. I'm going to multiply 11 out in front. So 1/11th times 11 is 1, without changing the inner function. So that's x cubed minus 4 to the 10th, multiplied by the derivative of the inner function. So that's 3x squared. The derivative of c, that constant, is just 0. So what I end up with is the integrand that we started with. They're the same. So the antiderivative we found was accurate. Okay, let's take a minute and realize what just happened here. What we noticed was that this integrand had an inner function. The inner function was x cubed minus 4. Because we had an inner function, I know that the derivative of the inner function must be involved in this integrand somehow. So I took the derivative of the inner function, and that gave me this right here. What I could do then is substitute. So this is where the name U-Substitution comes in. I was able to substitute out those x values so that they were all written in terms of u, to make this problem way more simple to solve. Once I wrote it in terms of u, I was able to just work backward from the power rule and then substitute my values of u back in again. Let's try another example. Let's see, let's go back to the green. Let's say this was the first one. I'm going to ask you to find this second one. I would like you to find the antiderivative of this, please. I'm setting these all up fairly nice for you, but it's okay right now. I want you to get used to this idea. So take a moment. I would like you to actually use U-substitution, and I would like you to try to find the antiderivative of this. Okay, welcome back. I hope you did try it. I see that there is an inner function. Since there is an inner function, I need to use U-substitution. The inner function is 3x squared minus 4. The derivative of the inner function is 6x, conveniently. I'm doing this on purpose. So du is 6x times dx. So what I can do now is rewrite this entire integral so that everything is in terms of u. That makes the problem way more simple to solve, and it helps me see the structure of this integrand. So if I replace the 3x squared minus 4, that is now u to the 6th. If I replace 6x dx with du, now I have u to the 6th du. If I find the antiderivative, I'm going to work backward from the power rule. So u to the 6th, the antiderivative is 1/7 u to the 7th plus some constant. Finally, replacing u again, u is 3x squared minus 4 to the 7th power plus some constant. Okay, let me find one that's going to be just slightly more tricky for you. Let's see. How about, I'm going to do 2 more. So, oops, yeah, this is right. Let's call this 8x 8x cubed times the square root of 2x to the 4th minus 10 dx. Give it a shot, find that antiderivative, and we'll come back and we'll do this together. Okay, I hope you tried it. So I'm going to rewrite this. It's going to help me a little bit to see this as 2x to the 4th minus 10 to the 1/2 power. I can see an inner function. The inner function is 2x to the 4th minus 10, so that's u. u is 2x to the 4th minus 10. du is 8x cubed dx. So now I can rewrite this all as a function of u. I have u to the 1/2 and 8x cubed dx is du. Finding the antiderivative, I'm going to work backward from the power rule, so I'll add 1 to that exponent first. That's u to the 3/2. And then I'm going to divide by 3/2. So that makes this 2/3. Final step, I'm going to replace u with 2x to the 4th minus 10. My pen keeps giving out on me. And that is the antiderivative. Okay, I'm going to do one more. And this is going to make you so happy because I'm going to use trigonometry, of course. We can't get out of a day without using trig. Let me see. So let's make this and this will be the sine of x cubed plus 5x. All right, pause. Give it a shot. I think you can do it. Okay, welcome back. I hope you tried it. I didn't quite leave myself enough room for the u on the side, so I'm going to put my u down below. I see an inner function here. The inner function is right here. So I'm going to say, I'm going to let u equal x cubed plus 5x. And du then is 3x squared plus 5. And if I move the dx to the other side, it's 3x squared plus 5 dx. So let's rewrite the integral. Instead of sine of 3x squared plus 5x, I will rewrite this as sine u. And then the 3x squared plus 5 and the dx is du. Okay, now this is just a trig problem. I just need to work backward from the sine function. So the antiderivative of sine is negative cosine plus some constant. If I replace u with x cubed plus 5x, that gives me the antiderivative. Now don't forget, you can always work this forward. So this is the answer. But if you're not feeling confident that you got the answer, find the derivative of this answer. If the derivative that you found is equal to this integrand that we started with, you did it correctly. So let's try it. We'll just do this one. We'll check our answer. Find the derivative of negative cosine of x cubed plus 5x plus some constant. Okay, the derivative of cosine is negative sine. And since this is negative of that, this becomes positive sine without changing what's inside. multiplied by the derivative of the inner function. The derivative of the inner function, that's 3x squared plus 5. And then the derivative of this constant at the end is 0. So this does indeed match what we started with. So you can always check your answer to make sure you did it right. Okay, go try some of these on your own.